yesterday we had discussed, we had started with our discussion about mathematics of growth, wherein we said that given a bacterial strain, you will see that it will multiply or it will double in number at constant time intervals. And we took an example that if you say E. coli multiplies every 20 minutes, you will see that in the first 20 minutes, you will have 2 cells out of 1 cell. In the next 20 minutes, the 2 will have doubled to 4 and so on. So we said that this constant time interval in which the population doubles up in number, we refer to this time period as generation time, or you call it as doubling time, correct? Then we said that this basically means that jitna time division hua, utne baar tumhara population double hote hue gaya hai, correct? So if you know that at the start of the study, you had a specific number of cells with you, which you call as N0, okay, which is the initial population at time 0, okay, then you will come to know what is the size at the end of this study. Say for 10 hours, we have incubated a strain in a specific medium. So after 10 hours, we will see what is the number. That would be NT, which is going to be the number of cells which forms the population in 10 hours. That is at time T. Okay. And from this, you can find out the number of generations, which means how many times did this cell actually carry out division process? How many times has it multiplied? So for that, we said that you have an expression called as NT, which is equal to N0 into 2 raised to N, wherein N0 is your initial cell number. NT is the cell number at time T. And we said that 2 raised to N, that N stands for the number of generations. We took an example wherein we said that if at the beginning of the study you had 100 cells, 100 cells is 10 raised to 2 cells, okay? And at the end of 10 hours of the study, you had 10 raised to 5 cells. So you have N0 value, you have NT value. N0 is 10 raised to 2, NT is 10 raised to 5. Okay, so using the expression that we have discussed till now, which is NT is equal to N0 into 2 raised to N, you can actually find out the value of small n in this case, for which you apply log. So it's going to be log of NT is equal to log of N0 plus n, that small n, into log 2. Okay, so further simplifying it, it will be n into log 2 is equal to log of NT minus log of N0. And small n is equal to log of NT minus log of N0 by log 2. And log 2, if you see the value, it's going to be 0.301. So small n, which is your number of generations, is equal to log of NT minus log of N0 upon 0.301. So is this clear till this point to everyone that we have discussed in the last lecture? Only then I'm going to move ahead in this expression. So have you all understood this much till this point? Just type a yes in the box so that I know. Everyone, huh? There are 86, 85 students here. All of you should respond. Okay. Amazing. So I'm happy to know that most of you have understood this. I am just scrolling through to check that if there is anyone saying no, so that I don't miss out even on a single student if there is a problem. Yes, in the meanwhile, I hope you all have seen the classroom notification. Did you check that? I have posted something on the classroom about test coming up on Saturday. So I hope that you have seen the topics, you have seen what is the test going to be about, how many marks, when, what's the deadline, everything is posted there. Okay. You also know the references. I'm also posting which topic has to be studied from where on the classroom in that list of references. I hope you are checking that also. That should make your work simpler. Okay. And please take it seriously so that you are preparing in bits and pieces for your exam. That will help you only in the long run, isn't it? Rather than studying everything at the end, this will help you to study it in bits and pieces, and gradually you will get prepared for your exam. Okay, so that's the purpose of doing that. Okay, let's quickly move ahead now and continue with where we were. So this is the point where we are right now. Okay, which means that this formula will tell me the number of generations that has been formed during the growth phase. Okay. Now, please understand that when I use the term growth rate, when I use this particular term, what does this indicate? This is going to tell me how much growth has taken place in a specific time frame, isn't it? Rate ye aate hi samajh jane ka that this is a time related concept, isn't it? So when I say growth rate, you have to understand that it has to involve time. Okay, so you are going to express this as mean growth rate constant. Okay, so mean growth rate constant, which is also abbreviated as small letter k, it is the number of generations. Obviously, number of generations tells you that how much time the multiplication has taken place per unit time. Okay, so growth rate constant, the mean growth rate constant or small k, is telling you how many times multiplication has taken place in a specific time frame. Okay, often as we say per unit time, let me tell you that often this is expressed in per hour, that how many generations have we formed per hour. Now, for example, if you talk about E. coli, you know that E. coli multiplies every 20 minutes. This is a known concept for us. Okay, so we know that in 60 minutes, which is 1 hour, how many generations would have been formed? Can you tell me? If 20 minutes may you form 1 generation, 60 minutes may how many generation you would have formed? 3. Good. So it would be 3 generations per hour. Correct? You all agree? So similarly, depending on the organism and usko ek multiplication round ke liye kitna time lagta hai, it should be possible for you to calculate this, correct? But हमको पहले पता होना चाहिए कि भाई उसको एक राउंड मल्टीप्लिकेशन करने के लिए कितना टाइम लगता है. जैसे कि अभी के सिनेरियो में हमको पता है कि E. coli को 20 मिनट लगता है. But it is not necessary that every organism is going to take 20 minutes only. So you will have to find that out. You will have to experimentally determine this. Only then we can come to a conclusion that it, is requiring this much time. Okay. So please understand that K is expressed as small n by t. Small n is number of generations, okay, per unit time. Okay, so if I have to substitute this, what was small n formula? Small n formula was log of nt minus log of n0 upon 0.301. This was n ka formula, correct? Into now this t. That will give me the value of k. Are you all understanding this? That if I have to calculate the growth rate constant, the mean growth rate constant is number of generations per unit time, which means n by small t. Small n ka formula we have already found out using the derivation that we have done till now. So that is log of nt minus log of n0 by 0.301. If I substitute that n over here, I'm going to end up multiplying it with small t. So it's going to be log of nt minus log of n0 upon 0.301 into small t. Is that very clear? Okay. Now let us assume that we are trying to find out that what is the minimum time that is required for a population to double up. So we are concerned only with here basically understanding that एक population को अगर 20 सेल था शुरुआत में तो उसको 40 होने में कितना टाइम लगता है. So which means that if my N0 is say 20 cells, I am concerned to find out NT, that is 40 cells, ये कब होगा? Correct? Which means I am trying to find out that NT is equal to 2N0 कब होगा? क्योंकि 2 of 20 is 40 cells, isn't it? So I am trying to find this out. That how much time does it require for a population to double? Okay? How much time is required for the population to double? This is called mean generation time. Or mean doubling time. Okay, it's called mean generation time, or it is called as mean doubling time. Okay, this can be indicated by G. Okay, please understand that this can be indicated by G. तो जब तुम ये स्टडी कर रहे हो कि NT is equal to 2N0 कितने टाइम में होता है, कितने टाइम में एक पॉपुलेशन डबल अप होता है, तो in that case T is equal to G. Then you're trying to estimate the mean doubling time. You are not continuing for hours and hours together. You are just focused to find out that how much time does it need for the cell to complete one cell division such that the population becomes double. So in that scenario, T is going to be equal to G. Okay. So now in this case, if I look at the growth rate constant formula, what was the growth rate constant formula? Log of NT minus log of N0 upon 0.301 into T, which in this case, T is equal to G. So I'll write it G over here. Okay. Now, if I look at this expression, NT is equal to 2N0. And if I try to substitute it over here, what will it become? Log of 2N0 minus log of N0 upon 0.301 into G. So that's going to be log 2 plus log N0, because if you extend log to both of these components, into sign becomes plus. You know this, you have studied logarithm, right? So log 2 plus log N0 minus log of N0 on 0.301 into G. Correct? अभी ये दोनों तो कैंसिल आउट हो गया, माइनस माइनस हो गया, करेक्ट? तो रह क्या गया? log 2 on 0.301 into G. log 2 is 0.301, नीचे भी 0.301 into G, तो ये भी कैंसिल आउट हो गया. Which means that if I have to find out what is the mean doubling time, if I have to find out the mean generation time or mean doubling time, it's going to be 1 by k. It's just switching them, isn't it? So if I have to find out the mean doubling time, I have to just find out the reciprocal of the mean growth rate constant. Let us discuss this again. और फिर उसके बाद भी नहीं समझा तो आप मुझे बताओ, ठीक है? मैं वापस start कर रहा हूँ. I'm starting it from the scratch. Till now, we knew that number of generations is log of NT minus log of N0 upon 0.301. इतना हमको पता था. अब हम बोल रहे हैं कि हमको पता करना है कि भाई मीन ग्रोथ रेट कांस्टेंट क्या है, यानी कि आई हैव टू फाइंड आउट कि कितने टाइम में ये ऑर्गेनिजम्स मल्टीप्लाई कर पा रहे हैं. ये मुझे अगर देखना है, मतलब what is the time frame in which they are multiplying. So then this mean growth rate constant is going to be number of generations by time. Okay. We normally express it as per unit time. Please mute yourself, whoever this is. This is really very irritating. Whoever this is, please mute yourself. Abhay, mute yourself, please. So it's going to be n by t, number of generations per unit time, normally expressed in per hour. I've already told you this. Okay. So here, if you substitute the n value, which is this expression, what will it become? Log of nt minus log of n0 upon 0.301 into t. Because this t is over here. So into t. This becomes my mean growth rate constant formula. इसमें से मुझे पता चलेगा कि कितने जनरेशंस बन रहे हैं पर यूनिट टाइम, पर आवर में कितना जनरेशंस फॉर्म होता है. जैसे कि इकोलाई के केस में हमने बोला कि भाई 3 जनरेशंस होंगे 1 घंटे के अंदर. ओके, बट इफ आई वांट टू फाइंड आउट दैट एक पॉपुलेशन को डबल होने के लिए मिनिमम कितना टाइम लगता है, then I am not talking about mean growth rate constant. I am talking about the mean generation time, or I am talking about the mean doubling time. Okay. In this scenario, we are talking about the time required to convert one cell to 2 cells, basically doubling up. So in this case, T is going to be equal to G. And here we are trying to see that when we are getting double the number of cells from the initial number with which we started. So keeping this in mind, if I look at the formula of growth rate constant, if I substitute nt is equal to 2n0 in place of nt, this is how my growth rate constant formula will now look like, wherein t is equal to g. If I extend log to this, it becomes log of 2 plus log of n0 minus log of n0 upon 0.301 into g. So this gets cancelled out. So this is going to be 0.301 because log 2 is 0.301 upon 0.301 into g. So you cancel this out. So this becomes mean growth rate constant is 1 by g. So which can also be rearranged as g is equal to 1 by k, which means that my mean doubling time is nothing but the inverse of my mean growth rate constant. Correct? Have you understood this, everyone?
Yes, sir.
Yes, sir.
I hope you are writing this down simultaneously. If not, I can give you some time to copy. Do you want some time to copy this down, everyone? सबने लिख लिया है?
Yes, sir.
Yes, sir.
तो अभी हम प्रॉब्लम सॉल्व करें इसके बेसिस पर, चलेगा?
Yes, sir.
एक प्रॉब्लम मैं खुद तुमको सॉल्व करके दिखाता हूँ. एंड you know what we are going to do is that every week we'll try to solve at least 2 problems. Okay, and gradually the complexity of the problems will go on increasing. We'll start with very simple problems and then gradually we'll go towards the tougher ones. Okay, so let's start with the first one. We'll solve 2 problems at least today. Okay, and we will see how you are able to cope with that. Okay, so let us begin with, say, this problem, which is from your book itself. It's a very basic problem. Let us say we started with n raised to 3 cells. In 10 hours, we have achieved n raised to, say, 9 cells. Let us say 9 cells. Okay. So can you now very clearly tell me what is n0 in this problem?
N raised to 3.
10 raised to 3.
10 raised to 3.
10 raised to 3. 10 raised to 3.
What is nt?
10 raised to 9.
10 raised to 9.
10 raised to 9. And what is t?
10.
10 hours. 10 hours.
Excellent. Now let us calculate the mean growth rate constant first. What's the formula of mean growth rate constant? Log of nt minus log of n0 upon 0.301 into t. That is going to be log of 10 raised to 9 minus log of 10 raised to 3 upon 0.301 into t. Now ये बहुत ही सिंपल है, log of 10 raised to 9, log to the base 10 के हिसाब से log of 10 raised to 9 is 9, log of 10 raised to 3 is 3, okay, upon 0.301 into 10 hours, correct? So this is going to be like 9 minus 3, what is that going to be?
6.
0.301 into 10, so I can write that as 3.01, which is nothing but 3. Okay, so I'm going to consider that as 3. So that's going to be what? 6 divided by 3, that's going to be
2. 2.
2 generations per hour. This is going to be my mean growth rate constant. 2 generations per hour में, ठीक है? अभी अगर मुझे इसका डबलिंग टाइम ढूंढना है, डबलिंग टाइम इज g is equal to 1 by k, so that is going to be 1 by 2, correct?
Yes, sir.
So
Yes,
what is the value that I'll get?
0.5.
Correct? Now what will be the unit? इधर generations per hour है ना, तो ये अभी उल्टा हो जाएगा, it will become 0.5 hours per generation. Generations per hour was the unit for mean growth rate constant, so you substitute it here, तो ये inverse हो जाएगा ना, अभी उल्टा हो जाएगा, so it will become
Yes, sir.
hours per generation. If I have to express this in minutes, what will be the answer? 0.5 hours मतलब कितना, आधा घंटा मतलब कितना?
30 minutes.
Have you all understood this?
Yes, sir. Yes, sir.
So can I give you a problem now? Will you try to solve it on your own?
Yes, sir.
Yes, sir.
ठीक, चलो. So I'm writing the problem here. Copy the problem now in your book. ठीक है? Okay. So can you tell me what will be the n0 over here?
10
10
raised
raised
to
to
6.
10 raised to 6.
NT?
10 raised
10
to
raised
6.
to 12.
20?
12 hours.
Can you now find G, K and G for me? And put your answers with units in the chat box, everyone. No one
Yes, sir.
it orally. You're going to type it in the chat box with units. Okay. Good. I can see that some of you have started typing the answers. Some of you still need to check your calculations. Please have a look at it. Okay, so it's very clear that it's going to be log of 10 raised to 12 minus log of 10 raised to 6 upon 0.301 into 12. Correct? That's going to be 12 minus 6 upon 0.301 into 12. That's going to be 6 by 3.6 or something like that. So that's going to give you 1.66 generations per hour. That's going to be your mean growth rate constant. Okay, while your doubling time is going to be 1 by 1.66, which is going to be 0.6 hours per generation. Okay, so all those who have got this answer, very good. You have done pretty well, but I can see some of you have made errors. So I hope you have realized where you have gone wrong. Yes? Any doubts about how to do this? Great. Amazing. So can I give you one step level up in terms of difficulty? Can I give you one more problem so that we try to go one step ahead in this?
Yes.
Yes, sir.
ठीक है, चलो, let's do that. So I'm writing the problem. Okay, do the calculation and let me know. I can zoom out a little so that entire problem is visible to you. Yes, now you can do the calculations, read the problem carefully and then do the calculation. Okay, and you can put in your values in the chat box. Okay, so I can see most of you have calculated it. It's going to be wherein it's log of 10 raised to 12 minus log of 10 raised to 4 upon 3.01 into 12, right? So it's 12 minus 4 upon 3.6, which is going to be 8 by 3.6. So your mean growth rate constant is 2.2 generations per hour, correct? And your doubling time is going to be around 0.45 hours per generation. Now 0.45 ko 0.5 mat karo. Don't do that. It's not a correct practice. Okay. Now on the basis of this, you were given a problem wherein they said that the earlier case wherein the organism was inoculated in nutrient broth, this were the values, correct? And now when it is in presence of lactose is the sole carbon source, you can see that the mean growth rate constant is like this, and this is the generation time, correct? So you can clearly see that even though there is a slight change, wherein you see that the doubling time in presence of lactose, what has happened to it? The doubling time has
Decrease.
decreased.
Decrease.
In comparison to nutrient broth, you see that the organism is multiplying much faster in case of the lactose containing medium. Correct? So you can have such comparative problems also. This is one of the basic comparative problems. There can be much more complicated versions of this wherein they include an antibiotic, they include some kind of a antimicrobial agent. So the complexity of the problem can change. But I hope this has given you an idea of how you will compare and accordingly interpret your results. Is that clear to all of you?
Yes.
Okay, so this marks the end of 1.1 section, 1.1a, 1.1b का हमारा पार्ट जो है वो अब कंप्लीट हो चुका है. ओके, आई विल वो जो भी मैंने लिखा है ना, ये डॉक्यूमेंट भी मैं पेस्ट करूंगा. पीपीटी मैंने ऑलरेडी डाल दिया है क्लासरूम पर. ये जो राइटिंग किया हुआ डॉक्यूमेंट है, दिस आल्सो आई विल पोस्ट एज अ पीडीएफ ऑन द क्लासरूम इटसेल्फ अंडर द सेम PPTs and references section, so that whenever you have some confusion you can refer to this. Okay, and I'll give you more. First doing 1.3. Okay, did you hear me or was there any connection issue? I'm sorry if there was.
Sir, I didn't hear you.
Yes,
Okay.
I had to hear it.
Okay. So I was saying that in our next session on Monday, we will first start with the 1.3 section. 1.1 complete हो चुका है. 1.2 हम फिलहाल होल्ड पे रख रहे हैं. हम पहले 1.3 करेंगे, which is factors affecting the growth pattern. जिसमें 4 फैक्टर्स हम स्टडी कर चुके हैं, पर उसको हम क्विकली रिवाइज करेंगे एक बार. और फिर जो 2 नए फैक्टर्स हैं, जो कि प्रेशर है और रेडिएशन है, that we will discuss once we are done revising the 4 factors that we have done last time. So can I expect you guys to read the 4 factors, that is temperature, oxygen, pH, and osmotic pressure, and come? You already have the presentation also with you. So just revise that. We will discuss that first, and then we will discuss the rest 2 factors. So 1.3 will get over, and then we'll go to 1.2. Okay? Is it okay with everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Great. So let's stop for today, and we will meet in the next lecture. Okay? Have a great weekend. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you.